Okay, this is 10.2, plane curves and parametric equations. This is kind of real stuff, more physics-based and science-based, but we're used to dealing with equations. A rectangular equation looks like this. It's y, or y in terms of x. This happens to be a nice parabola, which looks like that. Well, through some magic, which we don't really have to worry about in this course, but through some magic, we get an x and a y. Two equations that represent that one equation in rectangular. The reason why it's called parametric equations is because usually you want to know where something is with respect to time. So if I plotted x equals 24 square roots of t, 24 square roots of 2t, and I plotted y equals negative 16t squared plus 24 square roots of 2t, I plotted them, it's going to be this exact line. But now I get an idea of where things are in the x and y with respect to t. See, over here in the original, you don't have a time factor, so you can't add that extra variable. So that's why parametric equations are so important. This is called a plane curve. That's what they call them. All right, plane curve. And you'll know at t equals 1, when t equals 1 in both spots, this is what I get. The x direction, this is what's happening with x, that's where it is in y. When time is 1 or t is 1. Okay? So we use these parametric equations. They are x in terms of t, y in terms of t. Now, magic happens between going from rectangular to this way, but the other way is a little easier. This way, I don't think we have to know, to be honest with you, unless it comes up in the next slides. Here's a definition, and this is all on your advanced organizer. F and G are continuous. X is a function of t, and y is a function of t. They're not the same function, of course. They are called parametric equations. With t as the parameter, the set of all points obtained over this interval, over the interval, is called the graph. So taken together, the equations and the graph are called the plane curve. So the equations and the graph are called the plane curve. That's all we're asking. Now let's do some examples to understand. Oh, I never erased this stuff. I'm sorry. It's like the answers are given. No, I don't want you to close your eyes. Here, you can snack on a chip while I'm talking here. All right, you can snack on the chip. All right, almost done chewing, I'm sure. Okay, there you go. Nice. So now we need to show direction. With all these graphs, you need to show some direction. So here's the two I have. Also in your advanced organizer, I think I went to 3 in your advanced organizer here. Okay, I'm only going to go to 2. You'll get the hint. So what happens here, I'm going to fix my graph. Okay, I'm going to fix my graph here. And now I'm going to put in these numbers. When t is negative 2, x is 0. When t is negative 2, this guy is negative 1. So far, so good. I'm just filling in a table here. When t is negative 1, this guy is negative 3. That means this is negative 1/2. When t is 0, this guy's negative 4. That guy's 0. When t is 1, this is negative 3. And this guy's 1/2. When t is 2, this guy's 0. This guy's 1. And you know what? I'll go that extra mile for you because I love you. When t is 3, this guy is, I don't know, 5. Because 9 minus 4 is 5. And when this guy is 3, it's 3/2. So we're going to attempt to graph this. So let's graph this. 0, negative 1 is shown. Then my next point is negative 3, negative 1/2. Okay, so actually the graph went this way. Then it's at negative 4, 0. So here's negative 4, 0. Then it's at negative 3, 1/2. Negative 3, 1/2 is about here, coming around. And then at 2, it's 0, 1. So at 2, it's 0, 1. Excuse my scale. Then at 3, when t is 3, It's at 5 3/4, okay? So it's at 5, I don't know where that is, but it's probably up about here, and 3/4 is like 1.5. So 1.5 is right here. So then it goes up to that way. Okay? That's what it kind of looks like. You need to show the direction or the arrowheads, all right? You need to show that. And I don't know how straight this line is. It might be curved. If you take some points in between 2 and 3, you might get an idea of how it curves, all right? But there it is. That is a parametric equation. This is called a plane graph or a plane curve, okay? And this you need, once again, need to show direction. I'm kind of harping that, all right? Another example. Now another type of example. Graphing is not a problem, I think, if we have a table and we can do it. This is going to be more algebraic. We're going to eliminate the parameter. So basically what I want to do is make these two parametric equations go to rectangular equations. So we need to eliminate the parameter. To do that, we try to gotta get t equals something. So I'm gonna choose the second one and say t equals 2y. And now I'm just gonna take 2y and plug it in there and solve for y. So you choose one equation, you put the t, you get t equals, plug it in the other one, and solve for y. So it's going to be x equals 2y squared, quantity squared, minus 4, which means that it's x equals 4y squared minus 4. Okay, let's put the 4 on that side, so it's x plus 4. Let's divide by 4, and now let's take a square root. And y will equal plus or minus x plus 4 over 4. Or you could have, or you can window dress it and say it's this. Okay? That's equal to y. Take that square root of 4 on the bottom. All right? Any questions? Now, sometimes we use your favorite. We use trig functions when we do this. All right? X equals cosine of theta. Y equals sine of theta. Well, let's do 3 cosine theta, 4 sine theta. All right? With theta going between 0 and 2 pi, because these things can be cyclic. Actually, 2 pi and 0 are the same, so we'll make it strict. All right. Now, what we're going to have to do to solve this, or to graph it even, or see what it's looking like, is we're going to have to use some type of a trig identity. All right? The trig identity I'm thinking of is cosine squared of x plus sine squared of x equals 1. So therefore, I can do this. Cosine is x over 3 squared, plus sine is y over 4 squared equal to 1. And I don't know if you remember that, but that guy is a nice ellipse, all right, with negative 4. This is awful ellipse. Sorry about that, but there's negative 3 and 3. So if we had to graph something with sine, cosine, tangent, and I say remember some of those trig formulas. The last one we're going to attempt to do here is we're going to attempt to get this into one variable. All right? And by the way, that last problem, I could have got y equals, okay, y equals something, but you know it better in the general form of the ellipse. So we'll leave it like that. Multiple choice question, so you'll be able to see it. This one, we're going to get one in terms of the other. Well, the one I'm going to do that's circled in green here is I'm going to get t here. So to do that, I'm going to square both sides. So I get x squared equals 1 over t plus 1. I could flip these two. So t plus 1 equals 1 over x. And I'll subtract 1. Oh, I forgot to square it. My bad. Got to square both sides. So this is what I'm looking at. I'm looking at t equal to 1 over x squared minus 1. Now, what I'm going to do, I'm going to plug that back into here. Might get ugly, but we can do algebra with it. We're going to say, all right, this is 1 over x squared y equals 1 over x squared minus 1 all over 1 over x squared. The minus 1 and plus 1 will go out. Well, we can make this look nice. We can butterfly and make this, put this over 1, get common denominators, make it look nice. This could be 1 over 1 minus x squared all over x squared on the top and on the bottom. Oh, I'm getting close to my face there, I'm sure. 1 over x squared. So what's going to happen is these guys are going to go out, and you're going to get y equals 1 minus x squared as the rectangular equation for these guys. The rectangular equation that was given in parametric format. Remember that the domain here, domain, is x must be greater than -1. Okay, because of this right here. You always got to look back to the domain. Oh, let's go back. Look back here. Has to be greater than -1. If it's not, then you got a problem. So if we're doing this on an AP exam and you have to kind of explain or something, you just got to look at the domain. And the domain has to satisfy both. All right? And it kind of gave us the domain anyway. But I just want to let you be cognizant of that. All right? Now, I've got a couple of questions for you to do. All right? They are on the sheet. There's three examples there. Okay? It says, the first one, give me some love here. There it is. And I'm going to ask you to sketch curve. So you got to do a little sketching for number 1. And it's right on your paper. Sketch. All right. Number 2 and number 3, I believe, are, we'll eliminate parameters. Meters. That's like the T. Eliminate the T. Get it to rectangular. All right? Do those 3 questions. We'll talk about it tomorrow, and then I'll give you what was there in class. All right, take it easy.